Good day everyone, and welcome to Island Technologies presentation on using NAT in DREYTEC routers. My name is Java and I'm a technical sales specialist at DREYTEC Australia and New Zealand. If you have any questions during the video, please comment in the chat box on the right side of your screen and stick around at the end for a 5-minute Q&A session. If you're watching this after the live premiere, please comment below or send an email to sales@dreytec.com.au. We'll start with some basics of TCP/IP and NAT before going into more detail about port redirection, how and when to use the DMZ, open ports and port triggering, followed by an overview of ALG before touching on a couple of other NAT features available in DREYTEC routers. Before we discuss NAT and port redirection, plus the other features, let's start off with some TCP/IP basics. In an IP-based network, each device needs a unique IP address, whether it's a computer, printer, server, camera, or an IP phone. There are two types of IP addresses, public and private. Public IP addresses are used on the internet, and private IPs are used inside a local area network and are not usable on the internet. Down the bottom here are the private IP address ranges, which are reserved for use on internal networks. Different sites may use the same IP addresses over and over, as long as they do not communicate directly to other networks. But if different local area networks do need to connect together, for example, when using VPNs, then it will be necessary to have a different set of IP address on each LAN or use address translation. IP version 4 or IPv4 addresses have 32 bits, which gives us 2 to the power 32 IP addresses, which is approximately 4.29 billion combinations. And unfortunately, we've already run out of the numbers. We've been hitting the ceiling since 2011 for Asia and Pacific region, 2017 for Africa, and about 2019 for Europe and Middle East. A large part of the problem is that the number of IoT devices has been increasing exponentially as more devices like smart TVs become more and more popular. That's why for the last 15 to 16 years, network administrators around the world have been trying to implement IPv6, which uses 128 bits. That's 2 to the power 128 number of addresses, which gives us around 340 trillion IP addresses. You can see the exact number in the center of the screen here. One problem is we can't switch every device to IPv6 overnight, because not all devices support it yet. So we have a need for a transition stage where we have both IPv4 and v6 devices on the same network. To allow that to happen, we need routers and switches that can support both simultaneously. This feature is known as dual stack capability. For more details about IPv6, I'll include a link in the description below to our webinar on the topic. Now, here's a statistic that shows IPv6 adoption from the google.com/IPv6 website. The graph shows the percentage of users who've been accessing Google using IPv6 from 2009 to 2020, where it hit 35%. That number, of course, is expected to keep going up, and probably it's going to start increasing exponentially at some point soon. This diagram shows a simple LAN setup which all network technicians should be very familiar with. Here we see 4 devices on the local network, each with a private IP address. This constitutes a typical local area network compared to the internet, which is known as a wide area network or WAN. Our router at the top has a public WAN IP address of 123.24.25.1 while its LAN IP address is 192.168.1.1, and the devices behind it have private LAN IP addresses in the same subnet from 192.168.1.10 to 13. Usually, these IP addresses will have been assigned automatically by the DHCP server of the router. So, network address translation is a mechanism where one or more private IP addresses can share a single public IP address. Here you can see that the router is in action providing NAT, allowing several LAN users to access the internet using one WAN IP address. So any local user that's communicating with the internet will show the same public IP address, which in our example is 123.24.25.1. So far so good, but what happens if we want specific traffic to be directed to a specific device on our LAN? How will the router know which device to send that traffic to? To get around this issue, we use what is known as ports. For each WAN IP address, there are 65,536 ports for TCP and the same for UDP. You may use any external port as long as it isn't already in use by another device on the network, bearing in mind some ports are reserved for special purposes. For instance, HTTP uses port 80, HTTPS uses 443, and RDP uses 3389. So down the bottom there, we've decided we want any external packets going to our public IP address on port 85 to be directed to the PC with the private LAN IP address 192.168.1.10. Packets on port 86, we want to go to 192.168.1.11. Packets on port 87 to 192.168.1.12. And any packets on port 88, we want to go to 192.168.1.13. So how do we actually make that happen? The answer is port redirection. Port redirection allows external devices out on the web to access an internal device behind the router with a private LAN IP address. Now here's a typical scenario where we want someone out on the internet to be able to access an FTP server on our LAN on IP 192.168.1.12. FTP usually uses port 21. Visitors who want to access our FTP server can either use an FTP client or they can just add :21 after the router's WAN IP address in most web browsers. For example, 220.135.240.207:21. Now the router won't know what to do with that traffic yet, so our visitor won't be able to access our FTP server with that information alone. We need to tell the router that any traffic coming in on port 21 needs to be directed to our FTP server on LAN IP 192.168.1.12. This setting is found under NAT port redirection in Raytec routers, and pictured here is what the rule would look like. Mode can be single port or a range of ports. Bearing in mind that will also direct those ports to consecutive LAN IP addresses per the note down the bottom there. Service name can be anything you like. We've named this rule port 21, but we could have called it FTP or anything else. Protocol can be TCP or UDP. We need TCP for FTP traffic. WAN interface comes into play if you have multiple WAN connections and you want to direct traffic on port 21 if it comes from any WAN or only if it comes from a specific WAN. The public port for FTP is 21. Private port is also 21, but that could also be a different number if you want to get fancy and have our FTP server using a different port number, assuming the FTP server software allows for that. Now, source IP can be any if we just want anyone to be able to access our FTP server, as long as they have a recognized username and password, or we can lock it all down to a particular IP address or a group of IP addresses by creating objects down under the object setting menu. Private IP is, of course, our FTP server's LAN IP address, that is 192.168.1.12 in this example. Just referring back to port ranges, in a case where you need multi-host port redirection, where you have a range of IP addresses with a range of port numbers. In this example, we want ports 8080 to 8081 to be directed to consecutive LAN IPs 192.168.1.10 and 11 on port 80. Once we add our public port ranges and the start IP, the router automatically adds .11 for port 8081 to go to port 80 on the second web server. So in other words, we have two web servers using port 80 internally, but to get to them from the internet, visitors will go to either port 8080 or port 8081, and the router will then send the visitor to the correct web server based on the external port used. Another option is the DMZ or demilitarized zone. The demilitarized zone is an area inside the LAN where no ports are blocked. This is very convenient when you have equipment or an application that needs several ports to be open, for instance, a VoIP device. This screen shows a typical example where a DMZ has been set on WAN 1 so that traffic on any port is directed to 192.168.1.10, which is our DMZ host. Obviously, this will leave our DMZ host completely exposed, but our other LAN devices will still be hidden. To better protect our DMZ host, additional firewall rules will be needed to restrict unwanted traffic to the host. One application for DMZ is when transitioning phone services from the old PSTN system to NBN voice services. Often the NBN service provider will supply a basic VoIP router which is locked into their network, and it is very difficult to migrate the VoIP service to a VoIP-enabled DRATEC router if the ISP will not give you the SIP details. Now here the solution is to place the ISP supplied router into the DMZ of the DRATEC router as shown in the diagram here. I'll leave a few links below to more information about this on our NBN Solutions webpage, and also to an application note on the topic. This screen shows how you create a DMZ on a DRATEC router. First, select the WAN to be used by clicking on one of the tabs across the top, and then click on Choose IP to select the LAN IP address of the DMZ host. Now, what if you need the public IP address to appear to the device in the DMZ? A typical application is when you have a WiGA 130 in bridge mode. You'll find that you lose connection with the WiGA 130 when it's bridged because every packet just passes through it. The solution to this is to put the WiGA 130 in True IP DMZ mode. This setting is sometimes required for users who use gaming or multimedia applications. You can see in the bottom picture that the WAN IP 172.12.18.101 is being passed onto the PC in the True DMZ area. Now the screen shows how you configure the True IP DMZ host. To do this, just go to NAT DMZ host setup, select active True IP from the pull-down menu at the top, then type in the MAC address of the device in the DMZ. This will tell the router to pass on the public IP address to the DMZ host behind the router. You can also use this in a typical case where someone uses L2TP over IPsec VPN, is encountering issues due to incompatibility with NAT with IPsec. In this case, the VPN client will use the public IP address and the router will pass the IPsec packet through the NAT barrier without any issues. Note that this feature isn't available on all routers and is currently supported by the WiGA 130 and the WiGA 2620. An extension of DMZ host is where a router LAN port can be designated as a physical DMZ port with its own subnet. So now any device that's connected to that port will be in the DMZ. This is very useful if you have a large number of devices which need to be in the DMZ. Again, this feature isn't available in all routers. Pictured above me here is the front panel of the 3220 showing the designated hardware DMZ port. So what do we do if we want to direct more than one port to a single host on the LAN? Open ports is similar to port redirection, but it allows this to happen. Just be aware that incoming ports are not mapped to a different port number on the LAN side of the router. You'll find this feature also under the NAT heading in the router's menu. The screen shows how to open ports 25 and 110 to a LAN device with IP address 192.168.1.10. Note that the source IP can be an IP object or an IP group. Another thing we can do is forward a range of ports to an internal server by specifying the start and end ports. For instance, ports 25 to 35 and 110 to 120 here are to be redirected to our mail server now. Dratec WiGA routers support these three methods of port mapping to forward the traffic on a router's WAN interface to a specific LAN host and make it accessible from the internet. These are port redirection, open ports, and DMZ host. Also note the priority level of each of these methods. For example, if an incoming packet's port number matches a rule in both port redirection and open ports, then the packet will be forwarded onto the LAN address as defined in port redirection. Port triggering is a feature in WiGA routers that allows a host machine to dynamically and automatically forward a specific port back to itself. An example is connecting to an IRC or Internet Relay Chat server that needs authenticating a username with the identification protocol via port 113. When you log into IRC, you typically connect to the IRC server at a port in the range 6660 to 6670. To verify your username, the IRC server replies and makes a new incoming connection to your computer on port 113. This doesn't work if you're behind NAT because the router doesn't know which computer that packet is for. So it drops the packet and authentication to the IRC server can fail. Well, you could use port redirection or open ports to get around this. That will mean only one device on the LAN will be able to authenticate to the IRC server. And what if you have more than one? Port triggering is the solution. In the case of IRC, you can create a port triggering rule which will create a temporary port redirection to the PC that made the initial outgoing request. The trigger port is the outgoing port that the application uses. That's 6660 in this case. The incoming ports, that is port 113 in this case, are the ports used by the application for it to work. These are not opened until the corresponding trigger port is triggered and will be closed again after a set amount of time. This gives it more flexibility than static port forwarding because it is not necessary to set it up for a specific address on your network. allowing multiple clients to connect to IRC servers through the NAT router. Security is also gained in the sense that the inbound port isn't left open when not actively in use. ALG, or Application Layer Gateway, is a method of allowing certain media streams, for example VoIP and some video streams, to get across the firewall. ALG understands the protocol used by a specific application, such as SIP, that is the Session Initiated Protocol. A NAT router with a built-in SIP ALG can rewrite information within the SIP messages, that is the SIP headers and body, making signaling and audio traffic between the client behind the NAT and the SIP endpoint possible. Protocols like SIP, RTSP, and FTP will often fail when the service server is behind NAT. ALG is the solution to this problem. With ALG enabled, the router will replace the private IP with the public IP in the negotiation packet from the client and open dynamic TCP and UDP ports required for the connection. The screen shows how to enable ALG in DRATEC routers. The setting can be found under the NAT heading in the router's main menu. It doesn't work that well with a few applications though. So let's just look at a scenario when ALG needs to be disabled. The customer and associated tech support for the Avaya system have said that their system needs to see the external IP address of the connection in order to register it. In this case, we don't want the DRATEC router to present the modem's internal address to the phone system. Some of the entries in this log show the IP address 172.16.1.222, which is the LAN address of the DRATEC router, while some are displaying the external address in the private address field. According to the technician at Avaya, they need to be showing that external address in the IP address field and not the internal IP address of the modem. Disabling ALG in this case will solve the issue. As an update, nowadays, DRATEC routers have ALG disabled by default, and you can enable it using the GUI or through Telnet. Let's have a brief look into some other features of NAT. NAT Loopback is a useful feature added to DRATEC routers, and it's enabled by default. This works after configuring the open port redirection, or DMZ host in the router. Once configured, you can use the public IP address or the domain name to access the server from both your home or office network as well as from the internet. For example, the internal web server shown in the image here can be accessed by users in the local network using the public IP, that's 1.2.3.4, or domain name, that's example.com, thanks to NAT Loopback. FastNAT is a feature available in Linux-based routers such as the VIGA 3900 and VIGA 2960. It allows specific LAN hosts to skip inspection by the CPU and go to the fast NAT path directly. What this means is that the router will forward the traffic from a particular LAN to the chosen WAN directly. This function reduces CPU load and speeds up the performance of the NAT sessions. However, due to the traffic skipping, some features will not work on the fast NAT LAN, which includes the firewall. In the example that you see here, the VIGA 2960 is acting as the internet gateway for a university dorm, and there are hundreds of students accessing the internet through it at night, so CPU usage during the time is usually quite high. The network administrator would like to reduce the CPU usage and speed up the NAT performance of students' LAN using FastNAT. However, an exception is needed for the VPN network to let the students connect to the campus network. Okay, so that's about it. In summary, today we looked at NAT in DRATEC routers, starting with an explanation of TCP/IP, basic LANs, and how NAT works. We looked at methods to forward traffic through the NAT barrier to devices on the LAN, including port redirection, the DMZ, open ports, port triggering, and the application layer gateway option. And finally, we wrapped up with some additional features of NAT, including NAT loopback and FastNAT. That's about it from me, but please do stay tuned. We'll be answering any questions in the live chat on the right of your screen for the next 5 minutes. For more information about DRATEC products, please check out our website at www.dratec.com.au or send us an email to sales@dratec.com.au or just give us a call on 0298 388 899. Please like and subscribe below. And if you'd like a notification of new Premiere videos we're about to launch, or anytime we put up a new video, please give the bell a click as well. Thank you for your time. Bye-bye for now.